For centuries, humans have sought to understand the universe. What holds the planets in their orbits? What keeps our feet on the ground? What is time? What is space? Two of the greatest minds in history, Isaac Newton and Albert Einstein, dedicated their lives to answering these questions. But their answers were drastically different. One man defined the laws of motion and gravity. The other shattered those laws and replaced them with a new reality. This is the ultimate battle of scientific minds, Newton versus Einstein. Isaac Newton was born in 1643 in England, during a time of war and chaos. As a child, he was quiet, reserved, and intensely curious. When the Great Plague of 1665 forced Cambridge University to shut down, Newton returned home, where he made the discoveries that would change the world. For Newton's laws of motion. Newton formulated 3 fundamental laws of motion, describing how objects move and interact. These laws became the foundation of classical physics. Newton's laws explained everything, from the movement of a horse-drawn carriage to the trajectory of a cannonball. But his most revolutionary idea was yet to come. Universal gravitation, the great unifier. Newton's greatest achievement was the discovery of universal gravitation. The idea that every object in the universe attracts every other object with a force proportional to their masses and inversely proportional to the square of their distance. Newton's law of gravity explained why planets orbit the sun, why the moon stays in motion, and even why tides rise and fall. For over 2 centuries, his theories were considered absolute truth. But then, Einstein came along. Einstein, the birth of relativity. Einstein's early struggles. Unlike Newton, Einstein was not an exceptional student. Teachers dismissed him as lazy, and he struggled with the rigid structure of school. But Einstein's mind worked differently. He thought in visual concepts, imagining himself riding on beams of light. In 1905, while working as a patent clerk, Einstein published 4 groundbreaking papers in what became known as his miracle year. Among them was a theory that would shake the foundations of physics: special relativity. Special relativity, a new understanding of time and space. Newton believed that time and space were absolute. Einstein proved otherwise. He proposed that time slows down as an object moves faster, and that nothing can travel faster than light. His equation E equals mc squared revealed something even more shocking: mass and energy are interchangeable. This discovery laid the foundation for nuclear power and modern technology. But Einstein didn't stop there. In 1915, he introduced general relativity, a new way of understanding gravity. Unlike Newton, who saw gravity as a force, Einstein described it as a warping of spacetime itself. This concept was proven in 1919 when scientists observed light bending around the sun during a solar eclipse, just as Einstein predicted. Chapter 3: Newton versus Einstein, the battle of theories. Where Newton's laws work and where they fail. Newton's laws are still used today to design buildings, launch spacecraft, and predict planetary motion. But they fail under extreme conditions, such as near black holes or at the speed of light. Einstein's relativity takes over. Einstein's theories explain what Newton's couldn't. Without relativity, GPS satellites would be inaccurate because time moves differently in space than on Earth. Einstein's equations also describe black holes and the expanding universe, the future of physics. Yet, even Einstein's theories are incomplete. Quantum mechanics suggests that the universe behaves unpredictably at the smallest scales, challenging both Newton and Einstein's ideas. Today, scientists search for a theory of everything, a single framework to unite quantum mechanics with relativity. Could the next great scientific breakthrough rewrite the laws of the universe once again? Conclusion: the legacy of Newton and Einstein. Newton and Einstein were not rivals, but pioneers on the same journey. Newton laid the foundation, and Einstein built upon it, revealing deeper truths about our reality. Their discoveries continue to shape science, technology, and our understanding of the cosmos. And yet, their work is not the final answer, because science is an endless journey. If you enjoyed this journey through history and science, like, share, and subscribe for more mind expansion.